Welcome to Matt's Metalworking. In this video I'll be showing you how to fabricate a custom tube bumper. This bumper on the rear of this Tacoma has seen better days. A new aftermarket non-chrome replacement is over $250. I built this for just under $75 in materials plus time. First was removing the factory bumper, which is held into place with 4 20mm bolts. The factory brackets will be getting reused, and I'll show you this further on in the video. While everything was apart, I also cleaned up the frame as it was rusty from the rear axle back. If you're looking for a complete tutorial on removing the factory bumper, I do have a video on that on my other channel, and I will include it in the video description. I left the hitch in place for now, so I have something to hold up that bumper. If you don't have this, axle stands or concrete blocks can be used. To start out, I have a piece of 2x6 steel tubing, 3/16 of an inch thick. I would have preferred 1/8 thick, but this is all they had in stock, and this is a rather large step up compared to the factory chrome bumper, which is about a 1/16 of an inch thick at best. The total width of the bumper is 54 inches and 1/8. Thankfully, the metal supplier I purchased my materials from did cut the ends square, so there's no need to make any adjustments. Using some spray paint I had laying around, I applied it to the areas I'll be cutting so I can see my markings easily. I also have some 1/4 inch thick channel for the license plate area, and this will get cut down. One flange will be removed and it'll get squared up. Marking out the ends, my intentions here is to fold up these so the profile flows with the rear of the box, and I can still maintain that radius on the tubing. A triangular section will be completely cut out here. The one cut will run a 1/4 inch in from the bottom edge for a total of 10 inches in length. Making another cut line over on the outside edge, then meeting at the intersection point. This additional cut line is 1¼ inch above that 1/4 inch cut line. A scriber is used as the lines won't disappear from the heat like a marker or sometimes a paint marker. I can also keep the cut areas much more accurate, whereas a paint marker can leave a thick line. There are other methods for marking metal, and I'll cover that in another video. 4 of these areas need to be marked out, and make sure they are in the correct spots, being on the bottom of the bumper. Next is using a center punch to mark out the intersection points. These will be getting drilled. This will make it easier for cutting, and when it's time to fold in those edges, there won't be any interference at the corners, so it should give a clean bend. Next is drilling the holes, first adding some cutting fluid, then drilling the holes with a center drill. The center drill helps keep an accurate position as the bit doesn't wander or bend like a smaller bit. These holes can be opened up using about a 3/16 of an inch drill bit for more room for the movement. Next is cutting the sections out. This did take a bit of time and patience. It's always important to use the correct safety equipment when using any power tools such as safety glasses, ear protection, and gloves. Direct the sparks in an area where there's minimal risk of causing a fire or any damage. The grinder is equipped with a thin cutting disc. I did find the tubing to be under some tension, so it may want to jam up the blade. This can cause the blade to break or cause the grinder to grab. A wedge can be used to help open up that cut slot. Once that piece is removed, here you can see the holes came in handy at the intersection points. They're small enough where they can be easily filled up when welding, and you'll see that in a bit. Next is making the license plate area. I was originally hoping to get another piece of larger tubing of the same thickness. Again, this is what they had in stock at the time, so I had to make it work. The areas where the cuts will be have already been painted. As you can see, I have a license plate cover, and I'm using this as a reference for the size. One side needs to be squared up, and the other side needs to be cut down. Now cutting the channel to size, with the channel being 1/4 inch thick, I can thread holes for the license plate bolts instead of welding nuts on the rear or using nut certs. Using the big 9-inch grinder, I squared up the other side and cleaned up my cut. The 9-inch grinder has made life a lot easier. It would have taken much longer with the 5-inch grinder. Again, making another cut with a cutting disc, this time removing the lower flange. This is just a rough cut. Further on in the video, I did take another 1/4 inch off the bottom when the final adjustments were done. Now squaring up that cut using a 9-inch grinder. Determining the position of the license plate area, a section will be cut out so that the channel can be recessed in the bumper. I'm picking the center for mounting. However, it can be offset for a different look on the bumper or if you're trying to avoid any components. If you're considering to do any other modifications to your truck, the license plate can even be mounted on the tailgate instead, leaving the bumper with a smoother look. Now making that cut using the angle grinder, as mentioned earlier, I did find the tubing to be under tension, so the blade was jamming up. The channel will have a slight angle, so the bottom is tilted towards the axle slightly. Instead of cutting past the corners or drilling them, I finished up with a hacksaw blade by hand. Once again, the channel can be fitted. While I haven't shown this yet, I always finish up my cuts with a file to remove any burrs, so I reduce the chance of cutting myself on any edges. The top flange will also need to be cut down so it's flush with the tubing. I skipped this cutting part just to save a bit of video time. Now you can see when everything is in place, slowly coming together, side caps will be made for the license plate area so it's fully closed up. Prepping for welding, the mill scale does need to be removed along with any rust or paint. There is a variety of ways this can be done. I find the easiest way is to use a wire wheel. I will show another method further on in the video when it's ready for paint. Those triangular sections were also cleaned up, removing any metal which may interfere when clamping everything together. This was done with a file and grinding disc. Next is using a torch for those bends. There is quite a bit of tension folding over the ends. Heating up the metal will remove some of that tension. Clamp them into place, or at least as far as they'll go down at the moment. Heat up the area where the bend is located, then tighten the clamp more if required, and allow that area to cool. Moving on to the opposite side using the same process. While welding will heat up the metal, it may not heat it up enough to fully cover that curve. Using the heat allows for a sharper bend and reduces the chance of deformations. When that clamp is removed, the shape is held fairly close. Making the filler areas for the license plate. Cardboard is used as a template, first making the profile for the channel, then cut the profile to size. Putting the channel into place, the outside edge now needs to be traced out. And finally, once everything is cut to size, here is the mock-up of the filler portions. I have already cut the filler plates to size and used the section that was cut out from the tubing for the license plate area. I didn't cut the outer edges to size as they can be ground down after once it's tacked into place. The plates will be solid welded on the back side so I can maintain clean corners on the outside. I did chamfer the edge of the channel to help with penetration. The plates were also cleaned up to remove any mill scale. A magnet was used to hold the position of the plates, and they were tacked into place. Here I'm using a flux core welder with 35 thou wire. This is a thicker steel, so my heat range is higher. My welder only has a high and low heat position setting. When welding, again make sure you are wearing the correct protective gear such as welding gloves, a shop or welding coat, and a shield. Considering this is a flux core welder, slag is present and that needs to be removed before making more welds. A chipping hammer can be used, but I also find a wired brush cleans up the welds nicely. The plates were fully welded into place. Their position may have moved slightly with the heat, and this can be checked after everything is installed into place. The welds were also ground down flush so the piece can be installed in the tubing, otherwise it's too wide and won't slide in. The backside of the license plate area was cleaned up with a wire wheel, removing any paint, welding splatter, slag, and mill scale. Next is clamping down the ends of the tubing and welding everything in place. With the tension of the tubing, after cutting I found the walls to flare out slightly. Using a C-clamp can help pull them back in. As long as one side is flush, weld that one into place first, and then make adjustments to the opposite side as needed, as you do have one fixed position. Using the F-clamps, these will pull the cut portions down. Next is stitch welding everything into place. I'm not using tack welds, as this is a much thicker steel so it won't distort as easily with the heat, and the longer welds will be stronger, preventing any chance of deformation when I lay longer beads. While this is thick steel, it can still deform due to heat, which is why I'm not doing one long continuous weld. You may find it easier working from the inside out if the edges aren't lining up perfectly. That way you can make adjustments as needed, either using a clamp or hammer pushing everything in place. I even used a straight edge when possible to make sure those sliced portions are straight and square. An extra F-clamp can also be used to help pull the center in if it's curving out slightly. With the daylight disappearing, I finished up with cleaning the inside of the tubing where the license plate area cutout was. The area was sanded down using 220 grit sandpaper, and then a wax and grease remover was used to remove any contaminants. A weld-through primer is applied, so it does have some form of rust protection inside. The next day I did clean up the rear of the license plate backer with a wax and grease remover and then applied a weld-through primer again. Once that bumper is finished up, I'll apply a rust-inhibiting oil spray on the inside to protect any bare metal. Before the license plate backer plate gets installed, the edges of the opening was chamfered to help with penetration. I could have done this before applying the primer, as it is a weld-through primer which allows for welding. Putting the license plate area into place, the backer is tilted back slightly so it doesn't run parallel with the exterior face of the tubing. Clamping the backer into place using a C-clamp both on the top and bottom edges. The side filler plates are past the exterior face of the tubing. This will be ground down after welding. This will be a bit of a safety so I don't accidentally burn away the edge of that either. Tacking everything into place first. This time I'm not using stitch welds just in case anything pulls out of place from the heat. Then everything is welded in segments. I'm not running full beads again to reduce the chance of any distortion, and being that this is a smaller welder, I'm giving the machine a chance to cool down. The license plate backer is welded all the way around. I didn't have a chance to finish up my welding on the ends, so this was finished up today with solid welds. All my welds are ground down so everything is smooth for a seamless look. For this I'm using the 9-inch grinder. If you don't have a larger grinder, you can use a smaller one. It will take a bit more time, but it does the same job. With a larger grinding disc, it does help level out the surface easier. The license plate backer area was ground down as well. The side plates are now flush with the exterior surface. If you do notice any pockets in your welds, those will need to be filled. If there's any lines found in the areas you did weld where the two pieces of metal meet, that may mean that you either missed the area or the weld didn't have enough penetration, so this will need to have more beads applied. Once the areas have been roughed in, you can finish up with a file. The file can level out the surface, even clean up any radiuses and remove any rough marks from grinding. If you are aiming for a showpiece, applying a filler primer or even a form of body filler can be used. Then sand the surface smooth. However, I won't be doing any of that. With the Tacoma's oddly shaped box sides, I can't push the bumper in flush for more of a roll pan type look. In order to tackle this design, I decided to pull in the outside corners of the bumper on the rear. The ends will be cut a total of 6 inches in, then a 1/4 inch of material will be removed at the bottom, allowing me to pull the bumper in about a 1/4 inch. I'm trying to avoid adding any filler plates for this. Clamping the ends into place, this will allow me to make filler plates before taking out the welder again. As a little trick for making templates for the caps, place cardboard over the hole where the template is required. Then using a hammer, tap around the outer edge. The edge of the steel will give the cardboard a clean cut and create the exact size. A similar method to this is used for creating gaskets. I have already made my templates, and as you can see, it's an exact fit. Using the cutout section from the license plate area, this is the same thickness of steel and the templates can be traced out, then cut out after. Due to local laws, I'm required to have license plate lights, and I want to keep them a low profile to match the rest of the bumper design. I probably could have used the old light mounts, and it's certainly an option if you want to take an alternative route. Here you can see better how the license plate backer is angled in slightly. Marking out the holes, with the angle, I picked up a wider surface as the lights are just over 1 inch in diameter with the rubber grommets. There will be a light on each side, so 2 in total. The centers were marked using a center punch so the drill doesn't wander. Cutting wheel can be used here, first drilling the holes using the center drill. These could have been drilled before everything was welded into place, but metal can move when welding if everything's not fully secured. Applying more cutting oil and then using a step drill. The step drill does just fine in the 3/16 thick steel and can cut a very smooth hole. With the end still open and no caps welded into place, I can clean out any chips from drilling. The wiring will run inside the tubing for the license plate lights. Holes will need to be made on the rear. Again, marking out the holes using a square and scriber. These holes are slightly higher than where the wire is for the lights. Don't make them too far off as it can be harder to route the wiring inside. Again, the holes were marked using a center punch, then a center drill, and finally drilled to the correct size. Rubber grommets will be installed as a form of protection on these wires. These holes won't be sealed up with solid rubber grommets, so I'll have drain holes at the bottom of the bumper. And finally is marking out the drain holes, then drilling them. These could have plastic caps installed if you wish. As mentioned earlier, I'll apply an oil spray to the inside of the tubing as a form of protection against rust. Any spots or parts that will be welded need to be cleaned up using a wire wheel, remove any rust, paint, and mill scale. F-clamps were used to pull the ends together. It's only a small bend, so a torch isn't needed here. Measurements were taken to verify both sides are the same, then I tacked everything into place. Removing the clamps. Then it can be solid welded. The gap isn't overly big. Taking my time, I can fill it in with weld. The torch isn't angled towards the hole, but instead between the weld and the edges of the cut. If your angle is wrong, then you will burn through on the edges of the cut instead, making the gap larger and harder to fill afterwards. Allowing the welded portion to cool down, when the steel temperature keeps increasing, there is a greater risk of burning through. Running another bead on the other portion. Cleaning up those welds with a wire brush, removing any slag. The very corner will be left to cool down as it is a larger opening and I don't want it overheating where I can burn through easier. For the end caps, the edges were slightly chamfered and I used a magnet to hold them in place. The caps were first tacked into place only at the furthest ends closest to the corners. Then full beads were applied. I did find the tubing was slightly bowed outward. A clamp was used to square everything up again. And finally it is solid welded. Moving on to the opposite side, pushing down that sliced portion with F-clamps. Tack welds were applied to hold everything in place. Then the gaps were closed up. For an additional angle, you can see the angle of my torch and the weaving motion. The weaving motion gets wider as I work towards the end where the larger gap is. While it's cooling down, the end caps were installed. Tacking the caps into place, this side wasn't bowed out, so no clamp was needed. And finally, the end cap welds and welds at the bottom of the bumper were ground smooth. The large gap weld was left as is, but just cleaned up with a wire wheel. Next is cutting the bumper brackets to size. They were removed from the factory bumper. On the Tacoma, they are bolted into place. The factory brackets were installed back onto the truck, and as you can see, they do stick out quite a ways. Using a straight edge, I applied tape to the edge so it doesn't scratch the paint. Then I applied more tape to the edges of the box to protect the paint when test fitting the bumper. Using a square, make a reference line straight down to the brackets. I'm hoping the position of the tailgate is fairly accurate. A scriber is used to mark down the lines from the tailgate. I also used whatever I had laying around for a straight edge to make another reference mark for those portions on the box body. It's better to have the brackets longer and grind off a small amount of material at a time instead of cutting too much material off. Cutting down the brackets using an angle grinder. Making custom brackets is certainly an option. While these do have some rust, it's only superficial. These will be cleaned up using a wire wheel and painted. After the brackets were installed onto the truck, they do have a bit of movement with the elongated holes. I push them as far forward as possible. If the space is tight between the bumper and box, they can be pulled out slightly. Making a couple adjustments with a file, I was happy with the fitment and it's ready to be welded into place. The brackets and the areas they'll be welded to were cleaned up with a wire wheel. I used the F-clamp to hold the bumper in position and it's balanced on the hitch with a spacer block. I also made sure there's enough room for the spare tire cable drive cutout area. Right now I just stitched the bumper brackets into place and a final weld will be done when it's removed so I have enough room to work. Now the bumper can be removed and the brackets can be fully welded on. There may be some movements, so it's important to test fit this again after all the welding is done and make adjustments as needed. In order to add some strength to the brackets, I cut some gussets from what I had left of the license plate area. The corners won't be fully welded. As you can see, there is a ledge where dirt and debris can get trapped on and it may not wash out. First is tacking the brackets into place, clean up the welds using a wire brush, and then finish up fully welding the brackets and gussets. Moving on to the finishing stage. The mill scale can be left on if you wish, but it may not be smooth. not allowing for a clean final paint finish. Mill scale may even chip off after it's been painted. A wire wheel can be used. With a larger area, it's time consuming and it may be a bit more work intensive. To remove the mill scale, I'm using muriatic acid. First is mixing up a neutralizer with a bottle of water and baking soda added in. I would say there's about 2 to 3 tablespoons of baking soda added to 500 milliliters of water. Then shake up the mixture, ensuring it's mixed. For acid, when mixing, add the acid to the water instead of water to acid. This will prevent the acid from causing a reaction where it may splash out and harm yourself. When working with acid, it's extremely important to wear rubber gloves, extra protective clothing with no skin exposed, safety glasses, a respirator, and work in a well-ventilated environment. I have 2/3 water and 1/3 acid. The area should be free of any oil. There is a small pinhole in the lid of the bottle. Apply it to the surface. The surface can be agitated with a wire brush. In about 5 minutes, you should notice the steel surface cleaning up. When you're satisfied with stripping the surface, the acid can be washed away. Neutralizing the acid, pour the baking soda and water mixture onto the surface. You'll notice the acid foam up, which is normal. Allow it to sit for a moment and then rinse off with clean water. Flipping over the bumper, you can see where the acid dripped on the side and bottom shown by the clean areas. Do the same process as the opposite side. The acid will strip everything from the paint, rust, and mill scale. When it's done, the surface should be dried off immediately to prevent flash rusting. I wasn't able to do this as it started to rain after flipping the bumper over. Overnight, you can see the flash rusting was fairly superficial and can be cleaned up using a wire wheel on an angle grinder. Before paint, I marked out the license plate mounting holes. Next was drilling the holes. Using a tap and die chart, I drilled them out to the correct size for the tap I wanted to use. Apply cutting oil and finally tap the holes. This is 1/4 inch thick steel, so it should be plenty of material for threading holes. Here's a view while everything was being cleaned up, so you can see the design as it may be harder to see when it's painted. An alternative route can be using nut certs or welding in nuts on the back side of the backer plate. That cutting oil will need to be cleaned away using a wax and grease remover. Any holes or edges were cleaned up using a file. I made sure there was no burrs inside the light mounting holes as well. The metal was sanded using 320 grit sandpaper. I won't be using a filler primer here. A filler primer or even a filler can be used to hide any imperfections if you desire. Clean up the surface using a wax and grease remover. All contaminants must be removed so there is no issues with the primer and paint. As for primer, I'm using a etching primer which helps cut into the metal. Typically you can't paint over etching primer as it may have a chemical reaction with paint. However, this etching primer allows for a paint top coat. For paint on the rear, I'm using a farm equipment implement paint. I purchased this from a local farm equipment dealer. I do use the brush-on version quite a bit, and am extremely happy with its strength and durability. This is their spray paint version with a low gloss finish. Road debris won't stick as easily to the smooth paint unlike a bed liner coating, but it still provides an excellent protection. Once the paint is dry, the bed liner spray can be faded around the edges and only visible on the outside edges. I picked up some bed liner coating from a local hardware store. 1 can was plenty. I was having some spraying issues with the can. It would only spray upside down, and I am fairly certain it wasn't supposed to do that. 3 coats were applied. This coating dries very fast and does leave a great texture. After 24 hours of fully drying, here's the bumper before it goes onto the truck. On the rear, I installed rubber grommets. Considering it is cold out, I let them soak in hot water for a few minutes so they're soft, making them easy to install. Next is installing the lights. They clip into the rubber grommets. The grommets were installed first. The wiring was fed through the holes, and then the lights were pushed into place. I purchased these lights off Amazon. They came in a pack of 10, couldn't find anything smaller quantity-wise. They worked out to be about $1.25 each. There are 2 lights, 1 on each side. I installed the weatherproof connectors, and a special crimping tool is required for this. They do have rubber gaskets, so water or moisture can't penetrate the terminals. On the truck, the old connectors were cut off, and I installed a weatherproof connector on the other side. Being that I am using LED lights, these typically only work one way with an anode and cathode. I tested them out first to determine which side was positive and negative. All the wiring was cleaned up, zip tying everything back into place so it's not tangled up with the bumper and is ran close to the body, out of the way from anything that can damage it. Plugging in the lights, testing them out to make sure they do work. And finally tying those connectors back under the truck. Once done, here you can see the finalized bumper. I still need to install the hitch after it's been painted. I couldn't be happier how it turned out. A low profile bumper that should be much stronger than compared to the original version. While it doesn't have a step anymore, I can always add a step insert for the hitch. Additional features could be added if you wish, such as tow loops, flush mounting reverse lights, a hitch receiver, etc. This concludes the rest of my video. If you enjoyed it, please leave a comment below and throw a like my way. Don't forget to subscribe to my channel for more metalworking videos. Thank you for watching.